the fine details in the factory.
Both in structure, also when examined scientifically, leaves exhibit very detailed and complex systems specially created to ensure high-level energy production. In order to produce energy, the plant has to obtain heat and carbon dioxide from the outside world. The structures in leaves have been arranged in such a way as to obtain these two elements with difficulty. Leaves have external surfaces. The exchange of gases needed for photosynthesis to take place with ease. The leaf's flat shape means that cells are close to the surface. This in means that the exchange of and that can reach all engaged in photosynthesis. If, instead of a thin structure, leaves came in any concentric shape or at a meaningless and haphazard form, then photosynthesis could only take place in the regions in direct contact with the sun. To produce sufficient energy and the major consequence of this would be Earth. And the creation in leaves is by no means restricted to their shape. Leaf tissues are also highly sensitive to light. A leaf always faces the light. The way that plant leaves always face the direction from which rays reach them can easily be observed. Leaves are plants' productive facilities and are factories that produce nutrients. There are also laboratories in which chemical reactions take place. The greater the surface of the leaf, the greater its ability to work. For example, plants with broad leaves tend to grow in dense tropical forests. There are very important reasons for this. It is very difficult for sunlight to reach everywhere in quantities in tropical rainforests made up of densely packed trees. This makes a greater leaf surface area essentially to trap that light. In these areas where it's very little, it is vitally important for leaf surface if plants are to produce nutrients. This feature, tropical plants need sunlight from various in such areas to make the great use of it. In contrast, plants in dry, harsh environments have small leaves. Such climactic disadvantage in plants is water loss. As leaf surface area increases, so does less water loss. For that reason, the light-trapping leaf surface has been created to behave economically to best conserve water. Leaf restriction reaches the highest level in desert environments. For example, plants, this is carried out in the tree bud. The trunk is also where water is stored. This by itself is not enough loss. No matter how small a leaves, water will still be lost. A mechanism to balance evaporation is therefore essential. Plants possess a means of regulating excess evaporation, which they use by means of controlling the apertures of their pores, expanding and contracting them. Trapping light necessary for photosynthesis is not the only function of leaves. They also trap carbon dioxide in the air, and as photosynthesis is made is equally important. Plants perform by means of the pores on